Find all zeros, real and non-real, of f of x equals x cubed plus x squared plus 24x minus 26. Enter the zeros separated by commas. To begin, we need to find some initial zeros. The initial zeros we can get through what's called the rational zeros theorem, but that can take a while to come up with the possibilities. What we're going to do, which is a lot faster, is use a graph. So what I am going to do is take the polynomial that I'm given and graph that polynomial. So x cubed plus x squared plus 24x minus 26. When I graph this, I'm going to make sure I'm in the standard viewing window. So if I hit zoom and 6, that's the standard viewing window. And it looks like I can see a 0 here at positive 1. So we aren't certain of that until we prove it by synthetic division. But we're going to have to divide it out using synthetic division anyway, so let's get started. So 1, 1, 24, and negative 26. Okay, so if I bring the 1 down, 1 times 1 is 1. That adds up to 2. 1 times 2 is 2. This becomes positive 26. And that last column adds up to 0. So now these are the coefficients of a quadratic whose constant is 26. The linear coefficient is 2. And the quadratic is coefficient is 1. So what I'm saying is this function f of x is now factored into x minus 1, so I've changed this 0 to a factor, times the quadratic x squared plus 2x plus 26. Now it's just a matter of handling the quadratic. In the quadratic, we have lots of different ways of working with. We don't need to use a graph or anything else to try and find zeros. This won't factor. 26 is much too large to find values that are going to add up to 2, I believe. So what we will do is just go to one of our more advanced methods. The one I think I will use in this case is completing the square, because all the coefficients are relatively small and even values. So if I take 2 divided by 2, that's 1, and square 1, that's positive 1, so I just add that to both sides. So this factors into x plus 1 quantity squared. It's just half of this number that goes here. And this adds up to negative 25. So x plus 1 equals the plus or minus square root of negative 25. Or x equals negative 1 plus or minus. 25 is a perfect square. It becomes 5. And the square root of a negative is I, so this will be 5i. So the zeros, there are 3 of them because the original polynomial is cubic, are 1 and negative 1 plus or minus 5i.